Hi guys, today we're doing section 1.3. You're going to need a calculator, doesn't have to be a graphing calculator, your book, and a notebook. You should have a math notebook. If you don't have one yet, that's fine. You can just get scratch paper. But several days we're going to be using scratch paper and our book because your book doesn't have a lot of room, or I want to throw in some other examples. So it'd be nice if you didn't just have a bunch of loose pieces of paper, if you could get a math notebook just for some extra notes for honors algebra too. So today, what we're talking about is absolute value equations. So what is absolute value? I know you've heard of that before. Absolute value is distance to zero. So you don't need to write this down yet because we're going to be talking about this all day. But if I have absolute value equals 10, that means the distance to zero is 10. So I could be at 10 because that's a distance of 10, or I could actually be at negative 10 because that also has a distance of 10. Therefore, x could either be 10 or x could be negative 10. If I did another number, absolute value of this number is 3. So what values of x have a distance of 3 away from 0? 3 and negative 3. So a lot of times we're going to get two answers. We won't always get two answers. What about this one? Absolute value equals 0. How far is 0 away from 0? 0. That's the only number that's 0 distance away from 0, because there's no such thing as negative 0. So that's only one answer. So sometimes there's two answers, sometimes there's just one answer. And by the way, if there are two answers, they don't always have to be 3 and negative 3. For these types, they will be, but you'll see today, maybe we'll get an answer of x is 5 and x is negative 1. May not make sense now, but you'll see it in today's lesson. But I have no answers. What has a distance of negative 3 from 0? Well, 3 has a distance of 3. Negative 3 has a distance of 3. Who has a negative distance? Nobody does. So there are no values for x, or no solutions for x. We can get two answers, one answer, that's rare, or no answers. All right, go ahead and write this one down on your scratch paper. It says solve the absolute value equation. So I'm going to walk through this example with you. Notice the absolute value bars are right here. What we want to do is called isolate, or get by itself. So I want this to be by itself, kind of like on the previous page I did this, where the only thing on this side is the absolute value. I don't want any plus or minus anywhere. So the first thing you're going to do is subtract 1 on both sides. Now, this right here has a distance of 5. So this could be 2x plus 3, could be at 5 on the number line. That would be 5 away from 0. Or this same thing could also stand at negative 5 on the number line, because that also has a distance of 5. So once you have this isolated, once the only thing you have on one side of the equal sign is the absolute value, then you're going to actually apply the meaning, which means distance to 0. So this has a distance of 5, so I could be at 5 or negative 5. Notice that's when I drop the absolute value bars, because I've said that it could be at 5 or negative 5. From here, I just go ahead and solve these each separately. So let's go ahead and subtract 3. X is 1, subtract 3. Oh, so look at our answers. We got an answer of 1 and -4. Notice it wasn't 1 and -1 or 4 and -4. Let's look at how we can check our answers. I know that you guys know this because you've done math for a while. We can check our answers by plugging it in. So let's plug in a 1 right here. Let's do this together. 2 times 1 is 2 plus 3. So 2 plus 3, that's 5. Absolute value of 5 is 5 plus 1 equals 6. So that works out. Let's plug in our answer of -4. That gives me -8 plus 3. -8 and 3 is -5. The absolute value of -5, the distance of -5 to 0 is 5. So I can see both answers work out. Let's try another one. Write this down on your scratch paper. And we can always pause the video at any time if I'm going too fast or if you just need another second to process. Okay, so remember, we want to isolate. We want this absolute value to be the only thing on the left side of the equation. We need to get rid of the 2 and the -5. Just like a normal equation, we get rid of adding, subtracting first. So we want to add 5. Now, do not distribute. This is not parentheses. You're not going to distribute the 2. You're going to divide both sides by 2. Now we have isolated it. The absolute value is the only thing on the left side of the equation. As soon as that happens, as soon as you get it isolated, you know that this could be at 3. That has a distance of 3 from 0. Or all of this could equal -3, because it also has an absolute value of 3. Again, that's when you drop the bars, once you set it equal to 3 and -3. Go ahead and solve each. Our answers are 4 and -2. And again, you can go back up and check your answer, plug 4 in, and plug in -2. I'll go ahead and show you how to check one of them, even though you should check both. Let's check -2. So I'm going to rewrite the problem. 2. And then instead of x, I'm going to put my answer of -2. So I rewrote the whole thing. I just plugged in my x value. Let's go ahead and simplify the absolute value part. -2 minus 1 is -3. Now, the absolute value of -3 is 3. Since I applied the absolute value, I don't have to put the bars anymore. Now it's just a 2 times whatever this was, which was 3. So 6 minus 5, which does work out. So I know my answer is correct. Now, if you look in your book, you are going to see maybe a difficult math explanation of how this works, but you can read through this and see if it makes sense to you. I'm going to let you do that on your own time. I'm also going to let you look at example A on your own time. This might have been the one that we actually just did. It's just done for you. The book likes to work out some examples for you. But at the bottom, it does say, or let me show you the directions. It says, graph the solutions on a number line. So if these are my answers, when I graph those on a number line, it's nice to put in 0. That's an answer, and 4 is an answer. So that would be sort of a graph of my answer. Now, notice it's not an XY axis because there was no Y in this problem. It's only X. So you only have to do just the straight line. Okay, so if it says graph your answers, this is what it means. Just plot them on a number line. Okay, So at the bottom of page 11, you will see 4 problems. And we'll do the A and B together. I'll let you do C and D for practice. So it says, solve each absolute value equation, graph the solutions on a number line. So here we go. Part A, the absolute value is already isolated. So we know that this has a distance of 3 away from 0. So it could be located at 3, or it could also be at -3. Once the absolute value is isolated, that's when you can go ahead and drop the bars and show what the distance, what locations it could be on the number line. Solve each separately for x. And then if I want to plot those, I put a dot at 5 and a dot at -1, or a point. That's it. That's my graph. All right, let's try part B. Okay, first thing you want to do is isolate. So you don't want to just start by putting 2 equations like we did over here. You need to add 4 first. Now the absolute value is isolated, so this has a distance, an absolute value of 2. So it could be at 2 or -2. Subtract 1. So my answers are 1 and -3. Remember, you can always check it, especially on a quiz. It's a great idea to take this number, plug it back in, and also to take 1 and plug it back in. All right, why don't you pause the video and try C and D, and then I'll show you the answers. All right, going through the answers. For C, I'm going to subtract 4 first to isolate this. For -4 is 0. This is isolated. This has a distance of 0. So it could be at 0, or there is nothing else that has a distance of 0. So this is the only thing that I can write. I can't put -0. That's not really a number. Let's solve this one. Get x by itself. I get 3. 3 is the only answer here. 3 is the only x value of all of the numbers that when I do this, I will get 4. Letter D. I'm going to isolate. I'm going to move that 3 over. Now it's isolated, so this has a distance of -2 from 0. Can I be -2 away from 0? No. If it said 2, I would go ahead and set this up and solve them separately, but that's not what it said here. It said that the distance is -2. So when you get a distance is negative, no solution. That is not going to work. If you tried to do it, which I'm sure some of you did, take your value, whatever you did get for x, plug it back in, and you're going to find it actually doesn't work when you plug it back in. All right, flip the page. Number 1. How many solutions are possible for an absolute value equation having the form where A, B, and C are real numbers? So how many solutions can I have? Notice this is isolated and I have a value for C there. Well, let's look at what we had. We had, for part A, we had 2 answers. For part B, we had 2 answers. For part C, we had just 1 answer. And for part D, we had no answers. Those are all the choices. There can be 2 answers or solutions. Let's say solutions. 2 solutions, 1 solution, or no solutions. So there's a possible number of solutions. Okay, example B, I'm gonna go ahead and read here for you. It's done for you in your book, so we're just gonna learn from it and then do our own example. The temperature of a wave pool at Sapphire Island can vary up to 4.5 degrees Fahrenheit. That's how far it can vary from the target temperature of 82 degrees Fahrenheit. Write and solve an absolute value equation to find the temperature extremes of the wave pool. The temperature extremes are the least and the greatest possible temperatures. So we have two really important pieces of information. Our target, we would like the temperature to be 82 degrees. We can vary by up to 4.5. Now I know some of you could do this in your head or with a calculator, not write anything, but you're going to have to write an equation because that's what the directions are always going to say. And eventually you're going to get to harder problems where you're going to have to write an equation to do the problem. So step one, write an absolute value equation to represent the situation. Let T represent the temperature. So what you're going to do is you're going to take these important pieces of information and you're going to put the target on the inside in the middle. Kind of like if you have a target, I don't know the numbers on a, I shouldn't have written this, it's not a clock. Think of a dartboard. Sorry, that's what I was going for. Think of a dartboard, the target's in the middle. So that's how I try to remind students that target number is going to go in the middle here in the absolute value. Notice it's always T minus the target. It will always work that way. And the negative will work itself out and you'll see how that works. And then remember, this has a distance of 4.5. That's how far it can be away from that target number. So this is the number that it can vary by. Well, this is a pretty easy absolute value equation. This left side is already isolated. So this has a distance of 4.5. So it could be at 4.5 or it could be at negative 4.5. Add 82, you get this number. Add 82, you get this number. Which then tells me, here's my solution. The greatest possible temperature of the wave pool could be 86.5, and the least possible temperature could be 77.5. Those are the extremes, so those are my answers. Sometimes the question will say, what are the extremes? You'll have two set answers. Sometimes it say, what are all the possible solutions, or in this case, temperatures? Well, these are the only two acceptable temperatures. Those are the extremes. So to list all of the possible temperatures, we could say from the lowest to the highest. Any temperature that fits in there would be all of them. So read the directions. Does it say give the extremes, or does it say list all the possible? And here is a list of all of them. If I just want to list the extremes, I want the highest and lowest. Okay, so let's do one now. The pH of water is the measure of its acidity. The pH of the water of the seal slide can vary up to 0.3 from the target pH of 7.5. Use this information for parts A, B, and C. Write an absolute value equation that can be used to find the extreme pH values of the water of the seal slide. Be sure to explain what the variable represents. So the target, remember, goes on the inside, like a dartboard. The target's in the middle. So absolute value. My target, so I'm going to go with temperature T again, or you could say P for pH. So maybe we'll go with P minus 7.5. Always minus, always the target on here on the inside. Out here is how much this can vary by, how far away it can be from that, which is 0.3. That's all you have to do for part A. Oh, not all. We have to say what the variable represents. So go ahead and write down what P represents. That's going to be the pH value of the water slide, or the acceptable pH values. Part B is now I'm solving. So this is already isolated. So this equals 0.3 or negative 0.3. Okay, solve them each separately. So add 7.5. So we've solved it. Now I need you to pause the video and interpret your solutions. Your interpretation should be something like the highest pH value accepted is 7.8 and the lowest pH value accepted is 7.2. Those are the extremes. C, justify the reasonableness of your answer to part B. So you're going to do that on your own. All right, let's pause here for a minute. This is not in your book, so I just want to kind of introduce something. You can write this or you can just watch. So we've been talking about distance away from 0. So let's say I have the distance is 8 away from 0. That's going to put me at 8 and -8. Those numbers are the only values that are exactly 8 away from 0. Now, what if it says distance is less than 8 away from 0? Well, let's think about that. So if I'm at 8, here's 0 right here. 8 is exactly 8 away from 0, but I want anything that's less than 8 away from 0. So 7 is less than 8. All of these numbers are less than 8 away from 0. I also, on the other side, have 8 in the negative direction. That's also 8 away from 0, and all of these numbers are less than 8 away from 0. So if I'm over here 8, this would be x is less than 8, and this is x is bigger than -8. So you'll notice when I flip to the negative side, the sign also switches. Here I'm at 8 and I want smaller. That's why I put less than. Here I'm at -8, but I want numbers bigger than that because those are actually closer to 0. So when I put the negative of this number, it also then switches the sign. So keep that in mind as we're moving forward. Actually, I'm going to go back to a question. The very first one, I believe. Again, you can just watch this or you can write some things down. So this is one we did in the notes already. So we did 2x plus 3. We got this absolute value isolated, so we said that this is 5 away from 0, so it could be at 5, or it could be at -5. Then we solve them separately. So this first one is no different. That's an absolute value equation. Let's look at what happens when I have an absolute value inequality. Notice the only difference is this right here. This is not an equal sign. So you're going to start the same way. You still have to isolate. You still have to get rid of that 1 on the outside. Now, look at what this is saying. This is saying this has a distance less than 5 away from 0. So it's not exactly 5. It could be less than 5. You don't need to draw this number line yet. But if I'm at 5 and I want to be less than 5 away from 0, I can be any of those numbers less than 5. Or I could be at -5. But remember, that means I'm going to need to pick numbers bigger than -5 because I'm going the opposite direction. So I set this less than 5 or greater than -5. Over here it was equals 5 equals -5. Here when I do 5 and -5, the sign switches. Solve each of these separately. Notice my answers come out a lot alike. Here it was equals 1. Here it's, instead of equals 1, it's x is less than 1. So less than 1. And I'm at -4, and I want x is greater than -4. So this is my answer. By the way, I don't want you to write your answer, your final answer, as two separate answers if they go together like this. I would like you to put them together. So that's going to look like this. -4 is less than x, which is less than 1. Notice this is exactly what it says right here. And this is going over here. I just flipped the order because I wanted x to be in the middle. So I flipped everything around. That's why I flipped that sign there. So I should have one answer and one graph. All right, the only difference here from these two problems is instead of less than, it says greater than. So I start the same way. Now this is isolated. This is greater than 5 away from 0. So think of a number line. This isn't my final number line. I want to be more than 5 away from 0. So 5 in numbers bigger or -5 in numbers smaller. Those are more than 5 away from 0. So I'm going to put 2x plus 3 is less than -5. 5, -5. This sign is always copying the original sign. Then when you go to negative, you're going to flip the sign. Okay, solving each one separately. Now my number line for my final answer. It says x is greater than 1, so anything bigger than 1. X is less than -4. These numbers are numbers less than. Because these are two separate statements, it's an or statement, then you should be writing it separately, not into one continuous statement. Put the word or in there. All right, so this is an overview of pretty much all the types you might see. Now we're going to go to your book and do some practice. So we're on page 13. Yep, so page 13, you can read through this on your own time. It might be confusing, maybe you will understand it. Example C, you can do this on your own time. This is just an example done for you. I've already done some, so I think we're ready to practice. Notice I put some steps out here. Isolate the absolute value expression, write the two inequalities, solve the two inequalities. So first one we're going to do together. Part A, solve and graph each absolute value inequality. All right, this is already isolated, so this has a distance greater than 3 from 0. So I put greater than 3, or I put -3, but then I flip the sign. So I have isolated, that was already done for me. I just have written my two inequalities. Now I'm ready to solve them both. So I'm going to add 2. So let's say we'll put 5 here. So we have x is greater than 5, 5 and greater. X is less than -1. Here's -1, and these are the numbers less than. These are two separate statements, so I leave these separate, and I can write the word or in the middle. To check my work, I could pick any number bigger than 5, plug it in. Pick any number smaller than -1, and it should work when I plug it in. Let's try another one. Letter B. Isolate, so add 3. Now that this is isolated, this has a distance of 2 away from 0 or less. So it could be at 2 or less, or I could flip this sign and write -2. Now that I've written these, solve them each separately. I have my 2 answers. Let's take a look at how they look on the graph. So I have x is less than 0. Notice it says less than or equal to. That means I'm going to fill in the circle. If it says less than, it's an open circle. If it says less than or equal to, it's a closed circle. So it says x is less than, so I'm going this direction. X is greater than or equal to -4. Again, greater than or equal to, it's filled in circle. I want greater than. So any number in between there counts. You could try this filled in number, that will work. Also, if it's an open circle, don't try that number, but everything else. Because this is one continuous statement, I need to write these 2 statements into one. So I put the smallest number to the biggest number. You do have to show your work. So this is my graph answer, this is my numerical answer, and then this is all of my work. All right, go ahead, pause the video and try C and D. Here are the answers I get for C and D. I get x is greater than or equal to 1, or x is less than or equal to -1/5. So on a number line, I have -1. It's a filled in circle because it says greater than or equal to. Well, those numbers are greater than 1. -1/5 is about in here somewhere. I want values smaller. Again, you're showing your work. I'm just showing you your answer since we've done 2 together. Part D. This is what I get in my graph. -5, -4, -3, -2. Guess I'm only at -1. This should be an open circle because it doesn't say this. That's my answer. All right, so that is where we're going to stop. Hopefully now you can solve an absolute value equation or an inequality, and you can also graph your answers. Go ahead and get started on your homework now.